and everything is fine. And I hope my voice is perfect, audible to all of you. So today we are going to discuss about the probability distribution, its applications, and how we can use our dataset for the probability distribution, how we can write the code, and what are the types of the probability distribution. So all these things we will discuss during this session. Okay. And also if you have any question regarding yesterday's lecture, since the file which I share with you yesterday, the same file we are using in the today's session. Okay. So yesterday we talked about descriptive static, and basically many topic or the concept related to the same yesterday's has been discussed in the previous lectures also, but some more some specific applications and how we can use all these in statics. And sometimes we need to combine the visualization of our data set like KDE distributions along with the histogram, bar plot, etc. So, and how we can establish multiple graph of our data set in the single, just like matrix format. Okay. So all these we revise and some new things we add in yesterday's lecture, and all those are very helpful, very useful in our coming sessions, as well as whenever you need for your research or statistical purpose, you can easily manipulate for your data set. Okay. So data set we are using, either we can create our own data set in the Jupyter notebook by with the help of our own input. Okay. Or the other way, we can use the data set which is provided by Seaborn library. Okay. So the many, so we are using the data set from a Seaborn, okay, which is available and we can easily access. Okay. Sorry, I have muted to all the participants. Whenever we need, you can raise your hand. I will let you know to unmute your mic. Okay. Uh, Sometimes we forget to mute our mic and create some disturbance. So thank you. Uh, so I was talking about the yesterday's content. Okay. So and all those are very useful, and you can easily manipulate your data set, whether it is you are using from CSV file, Excel file, okay, or you create your own data set. We can easily read the file from any format, okay. And also Seaborn library provide lot of type of the data set, and we can easily use for different type of the experiment. Since once we are able to use all these uh, data set, mainly large data set. Okay. So then after how we can integrate the other methods, probability distributions. Okay, we are going to discuss today mainly just like binomial distribution, Poisson distribution, and continuous. Then we have the continuous like normal exponential distributions. Okay, so this type of uh, distributions are really very helpful and are the fundamental in statistics and help model real world phenomena by determining the probability of a different event. Okay. So first, I would like to share my screen, and my screen is visible to all of you. Okay. And these are the content which I am going to talk about these content, which are very highly useful, specifically uh, all type of the distributions. And I try to make all these content as simple as possible. Theory part, along with their formulas, expressions, symbols, I try to introduce so that these content as simple as possible to understand. Okay. No presentation is required. Okay, so everything along with the formula, we have the data set and the programming is there. So when you talk about one topic and everything, uh, theoretical as well as the formula, as well as their application along with the programming. So everything is inside in the single file. So everything after reading the content definitions, you can easily use all these files. Okay, so here this part we have discussed yesterday, and I have to start from uh, yes, section 4.2. Okay, 4.2 deal with, yes, this part has been discussed, and now here is our, yes, this also has been discussed, box plot, etc. And 4.2, section 4.2. This is the summary. You can use all these formulas, okay, uh, for the uh, summary static in pandas. Then correlation. Okay. Yeah, yes, this is the section 4.2. And we are talking about probability distribution. So first, this is the brief introduction. Probability distribution describe how the values of a random variable are described. They provide the likelihood of a different outcome occurring and can be classified into discrete as well as continuous. Discrete probability distribution include just like, for example, binomial and Poisson. And for the continuous distribution, we have the normal and exponential distribution. So these distributions are the fundamental in statistics and help model real world phenomena by determining the probability of different event. So they are used to summarize data, make prediction, and conduct hypothesis testing. Okay, so understanding the probability distribution is essential for analyzing data, making prediction, and building statistical model. So in this session, we will break it down in the several topics, okay, and we will cover one by one. So these are the segment which I create in this side, this topic. So well, very first we have is the uh, introduction about the probability distribution and what they are and why they matter. Second, then after we have the normal distribution, binomial distribution, Poisson, and then there will be like exponential. So four distributions are there. So we will discuss all these one by one. Okay, and along with their application. So actually, when we are talking about any distribution, so why and where we can apply one particular and what are the importance, what are the applications. So all these things are very, very, very important. Okay, so here we you can see. So very first we have is the introduction and their types. So probability distribution is a mathematical function that describes the likelihood of different possible outcomes in an experiment. Okay, and the probability distribution are essential in statistic, data analysis, and machine learning to model uncertainty and random phenomena. So this is the basic import about the what is the probability distribution and what are the types. So mainly there are two types of the distribution. One is the discrete probability distribution, and in discrete probability distribution will involve like Bernoulli distribution for binary outcome. Okay, success failure. There will be two type of the possibilities. Either it will be success or failure. And then we have the binomial distribution for the number of the success in multiple Bernoulli trial, and Poisson distribution for modeling the number of event in a fixed interval. Then we have the continuous probability distribution and applied to scenario where outcomes are continuous values just like height, temperature. Okay, these are the examples. And continuous probability distribution involve just like we have the normal distribution, and then we have the exponential distribution, which is used for modeling time until an event occur. And the normal distribution, in the previous lectures we discussed about the normal distribution, and when we plot the graph, will be always like a bell shape, okay, and widely used in data science. And uniform distribution, equal probability for all values within a given interval. So these are the two types of the, there are some more distributions are there, but here we deal only with this binomial, Poisson, then normal and exponential. So these four are highly useful in data science, machine learning, and prediction models. Okay, so now what are the key properties of these probability distributions? So here a probability mass function describes the probability of each outcome in the discrete distribution, and probability density function describes the probability for continuous distribution. Then we have the cumulative distribution function represent the probability that variable take a value less than or equal to given point. Then we have the mean expected values, just like we have the central tendency of the distribution. Okay, and the last two are, one is variance and standard deviation, measures the separate or dispersion of the data, how our data is separate. Okay, so these are some few key properties. Then we have the applications of the probability distribution where we apply. Okay, so all this type of the probabilities are have the applications for risk analysis, predictive model, hypothesis testing, quality control in manufacturing, stock market analysis. So these are some applications. There are more applications, but just we have the mainly these which we can have the examples and we can easily introduce. Okay, so we can have the application of these distributions in health science, in environment problems. Okay, so the probability is everywhere, so we can apply for different purpose, and these are the few examples where we can have the application of probability distribution, just idea. And now we talking about one by one. Here is first is normal distribution. Okay, so when we will expand every distribution one by one. So here again, we have the definitions, their key features, their applications. Then we have the example. Okay, so one by one, we will discuss now in very detail. Okay, so here the normal distribution, also known as Gaussian distribution, is one of the most fundamental probability distribution in statistics, and it is widely used in the fields such as science, engineering, economics, and machine learning. Okay, so and highly useful. What are its key features? Uh, yes. So here you can see when we have any data set and plot the graph of the normal distribution. So bell-shaped curve, the probability density function forms a symmetric bell-shaped curve. Secondly, mean, median, and mode are equal. All three measures of the central tendency coincide at the peak of the distribution. So where when you will have the this normal curve, so at the peak point, all these three will meet together. And symmetry. Okay, so the distribution is a symmetry about around the mean, and the meaning uh, probability of x less than mu will be equal to probability x greater than mu. Mu is symbol for mean, and defined the two parameters. Okay, so these are the two parameters. One is mu, which is determine the center of the distribution, and the next we have the standard deviation. Okay, so here why it is not sigma. Okay, so here we have to use this symbol and this symbol and the shift and enter. Shift and enter. Okay. So yes, now it is fine. So this is the symbol. You can see here for the standard deviation, we are using sigma sign. Okay, so here you can see the empirical rule. About 60% of the data fall within one standard deviation of the mean. Okay, when we have about 60%, then this is the one mean. Okay, one standard deviation mean mu plus minus sigma, and about 95% of the data falls within two standard, and we have the mu plus minus 2 sigma. Okay, and when we have about 99.7% of the data falls within the three standard deviation, like we have mu plus minus 3 sigma. Okay, so this is the empirical rule, and you can see here the equation. Okay, 68, 95, 99.7 rule. So this is the rule for this normal distribution. And here is the mathematical formula. Okay, fx, the probability density function, okay, FDP of a normal distribution is given by, you can see, and we all have studied this formula. Fx is equal to 1 upon sigma and root 2 pi e raised to power minus x minus mu whole square upon 2 sigma square. Okay, so this is the expression for the normal distribution, and by using this formula we can have the curve. Okay, so here the value x is the variable, mu, which is used here, the symbol is mean, and sigma is standard deviation. A is Euler symbol. The value of A is approximately 2.718, and that of pi is also there inside this formula on the right hand side. The value of pi, we all know that this is the mathematical constant, and the value is approximately 3.1416. Okay, so this is the method of formula which is defined normal distribution by the definition. So is we are given, we have to adopt. Okay, so the all the variables also explained here. X variable, mu constant, sigma is also constant. So mu, sigma, a, pi. Mu we need to calculate, sigma is the standard deviation, e and pi are constant. Okay, so what are the application of normal distribution? Here we can find various applications, natural phenomena, height, IQ score, measurement error, and blood pressure follow a normal distribution. Then we can have the application for the quality control used in the process control to monitor variations in manufacturing companies. Okay, we can use normal distribution in the finance, just like for a stock return, risk assessment, portfolio optimization often assume normality. Okay, and in the machine learning, many algorithms, just like we have the example naive-Bayes Gaussian mixture model, rely on normal distribution. Okay, there are various types of models are there which rely on normal distribution, but here we put only the two examples. Okay, so now the thing is how we can generate a normal distribution. So this is again very quite simple, but we have to follow the formula. Okay, formula is very, very important, and without formula we are not able to visualize, or we are not able to generate normal plot of a normal distribution. Okay, so see here, these are the required libraries. First thing is required libraries, NumPy and Matplotlib are there. We need to since we need to visualize in graphical form. Okay, so and NumPy, you know the importance of NumPy, which is used for the numbers, and we can easily perform different type of the operations by using NumPy, and we import NumPy as NP, and matplotlib.pyplot as PLT, and also from scipy.stats we will import norm. Norm is function for normal distribution, and we will use it as it is. Okay, so now we have to define here the parameters. We have mu is equal to 0. This is the mean. Suppose that mean is 0 and sigma is 1. Okay, you can manipulate all these values according to your need. Okay, So sigma is 1. If we are given some data set, so from that we can easily calculate the value of mean, we can calculate the value of sigma. Okay, but here we define ourselves. So these are the values which we taken at the place mu is equal to 0, sigma is equal to 1, and this is the line space range on x-axis. So the range we are taking here is mu minus 4 sigma, mu plus 4 sigma. Okay, we can take these values 1, 2, or 3. Okay, so we are taking here the value is 3 and 3. Okay, C come back. See this part. Okay, if the data is 68%, then falls under 1 mu plus minus sigma. Okay, and if about 95% data, a 2 standard deviation, that is mu plus minus 2 sigma. And if the data falls 99.7%, then we have mu plus minus 3 sigma. Okay, so here if this is the only the example. So this is the interval mu minus 3 sigma to mu plus 3 sigma. Okay, and this interval we will divide into 1000 point. Okay, you can manipulate this point according to your need. No impact, because these are the only the important thing is this interval. Okay, and you can divide this interval into sub intervals by taking the number of points. Okay, so these are the number of points, and then after we need to compute the PDF. Okay, by using the probability distribution function. So we are using this norm. Okay, and inside norm we have PDF, norm dot PDF, and you know in normal distribution we have x, mu, and sigma. Okay, so here x comma mu comma sigma, these three values are required. A and pi, these are fixed. We are not required to assign these values. Okay, these are constant. So here we the function which is inbuilt in Python. Okay, so in this like just like scipystat. Okay, so here only the values which are manipulated or which can vary. So only those arguments are required to put here. So when you will use this norm.pdf, only these three values are required. Okay. So E and pi both are fixed. We need not required. So the value x is variable, mu is which we calculate at this place, and sigma is also 1. Okay. And then after we have the image normal distribution plot. For that, we are taking PLT dot figure size. We are taking at this place 8,5. Then we have the PLT dot plot. X is the variable, and the PDF, the values of the PDF. Okay, by using PDF function. Okay, so these are values stored at this place. So here is PDF. Then we have the X label. We can assign the X label. Sorry, we have assigned the label for these values, and color is B. Then we have the X label, Y label, and title. So these what we have the on x-axis. This is the probability distribution on the Y label, and the title we have is the normal distribution. Legend will be for this value. Okay, and grid is there. PLT dot show to show the graph. So when we will, so first I have to check the libraries are there. Yeah. So the required libraries are also there inside this shell. Okay. So what you will do, you to run the code, shift and enter. Yes. So when you will shift and enter, we have this graph. You can see here, this is the normal distribution, and here You can check everything. Okay. So -3 to 3. The interval is -3 to 3. Okay. And since the value which we choose here, mu is 0. You can see the value of mu is 0. The mean is 0. That's why we have, this is the minus, and the value of sigma is 1. Okay. So the interval according to these values we have is -3 to 3. Okay. And when you can see this is the normal distribution, and this will be always symmetrical about the peak point. Okay, we take the mean is 0. You can see this is the value 0. Okay, so this is symmetrical about this line, you can see, and this is the peak point. Okay, and if you want to manipulate these values, say if suppose that the mean is not 0. Okay, suppose it is 5. I am taking the mean is 5. Okay, and standard deviation sigma can have the value 0.75. And when you will again execute this shell, you can run from this place. Okay, so yes, so now you can see the interval varies from this point to this point. Okay, and now see at this place this value. Okay, the mean we chosen at this place is 5. Okay, so as soon as you will play with the values of the parameters which are involved inside the normal distribution, so according to that this shape will change. Okay, and whenever you have any kind of data set, and from that data set you can easily calculate mean of the parameter. Okay, and you can calculate its standard deviation as we do in the previous lecture. The same process is there, no problem. And then after just you need to put the value of the x variable as we do here. Okay, as we do here, x the value of mu, sigma, and what is the line space. Okay, so this is the just like here we are taking the line space, but x you can have just like one array which will vary from one to the other point. Okay, so array itself has one type of the length, initial point and the last point, minimum value and maximum value. So minimum value and maximum value. So here also this is the minimum value and this is the maximum value. Okay, which represent the interval and all the point which we calculate here inside these two values. So in this way we can establish the normal distribution, and applications we already discussed in the beginning. Then after you can see uh, here in this example, what is there in this example? We choose we are using the Seaborn as SNS. We can use the Seaborn library, and this is useful when the data set is very large. In that case, we always use Seaborn. Okay, and this library has some more advanced features as compared to Matplotlib. Okay, so these are the libraries which we are using for the data set which we generate randomly. Okay, so here you can see generate the synthetic data. Okay, and later on we can replace. I mentioned here you can replace this synthetic data with our actual data. Okay, so DP data is we have np.random.normal LOC 50 and scale is 10, size is 1000. Okay, so here LOC 50 mean, STD is 10, size is 1000. Okay, so see here, this is the mean. This is the STD standard deviation, and these are the point. Okay, size. And here we have to fit the normal distribution to the data. So from this synthetic data, which will be generated here, and by using this one, we fit a normal distribution to the data by using we need mu and sigma both. Okay, so here for the mean, okay, here on the left hand side you can see two variable are there, mu and sigma, and on the right hand side also this is for mu and this is for sigma. Okay, so np dot mean data and np dot std data. So from this we can easily have the value of mu and sigma, and will store inside these two symbols. And then after what we do here, we have the plot histogram and normal distribution curve. So from this data set, two things are there. One, we will plot the hist plot, and secondly, the KD curve is also there. For KD curve, we can easily plot in hist plot. Okay, hist plot we can easily just we need to assign here KD curve, and we discussed many times in the previous lectures. And along with we need to insert the normal distribution, and that will be calculated here. See, generate x values for the normal distribution curve. X is equal to, we are taking np dot line space minimum data and maximum data, a minimum value of the data and maximum value of the data, and 100. So this will generate the line space. 100 point will be there. After that, we have the PDF. Okay, as we do in the above, we have the same process. Norm.pdf x comma mu comma sigma. Okay, now we have two graphs. One is histogram, which is at its place. Okay, and second is normal distribution, which will be generated with the help of this one. So what we do here, see, by using plt.plot x comma pdf. Okay, this is used for normal distribution, right? And color R is red color, and this is the label we are using here for normal fit as well as for sigma. Okay, the value of sigma and that of mu, both values are required. Then we are using the X label, Y label, title, legend, and show. So see what happens when we will execute these statements. Yes, you can see in this graph very carefully. Okay, you can see here on the horizontal line we have the data values from 20 to 80, 80 plus something. Okay, about 82. And inside the histogram, there is one curve in the same color, just like blue, light blue. Okay, this is the KD curve. Okay, KD curve is also help us how the data is distributed. Okay, and this histogram also help us to know about the data distribution. Okay, and also we have the normal fit. You can see this is the normal curve. Okay, this normal curve is fitted here for the data set which we generate. Okay, so we can also, whatever we have the data set, we can we can calculate the normal distribution, how is the data is distributed. Okay, and you can see here also normal fit, the value of mu is 50.37, which is computed by giving our input, and the that of value of sigma is 10.43 computed, and the red line showing the normal distribution. Okay, normal distributed curve. Okay, this is the curve, and here the tips data is well known data set in Seaborn and containing information about restaurant tip. So the data set we can, I think there is one more example by using the restaurant data. Yes, here is in the next example we are taking the data from restaurant. Okay, So here you can easily compare the caddy curve and the data, and mainly when the hist beans, most of the beans are under this normal curve. You can see most of the beans are under this normal curve, and when this happen, number of the beans are under the this normal distributed curve, then we have the data is well distributed. Okay, so it depends upon how our data is, how many beans are under this normal curve. So according to that, we can easily study our data is how much accurate distributed. And in the next example, we are loading the data set from Seaborn. As I told you that, Seaborn itself provide us a data set and we can use. But here, restaurant data, restaurant tips. This data is there and we will use here. Below is the Python script. So we will load the data set and then after we will plot the normal distribution of the total bill column. Okay. So before that, before discussing this part, if there is any question, you can unmute your mic. If there is any question, you can unmute your mic. Okay, I have to allow you. Yes, now you can do. If there is any question, otherwise we are talking about this new example. So here we will use the data set. Any question, please?
Thank you, sir. No question. Thank you.
Okay, thank you. So here you can see as sometimes if we don't have the data, but we want to use. So many times I told you that Seaborn library provide us some data set which we can use for our experiment, our visualization for the use. Okay, and from that importing and we can use it. And if you have your own data set in your CSV file or Excel sheet, you can also import the data set inside the Python and we can use. Okay, so we all are say beginners and we want to know how we can use data set it and how we can have this type of the curves which are highly useful in just like machine learning, data analytic, and to establish various type of the models. Okay, so these sequence of the statement using the Python and its libraries will help us to use. And once you will do this experiment yourself, go through all this detail, what are the syntax which we are using will help for the better understanding. And once you will do for this normal distribution, for the other, just like the binomial or you can use this same sequence of the statement and little bit there will be a small difference. So here these are the same required libraries as we do in the above example, but only the new thing is that we are using tips dataset from Seaborn. Okay, and from this place we will download the dataset. Okay, or you can import your own dataset. Okay, so here then after we will use the total bill. We are using for total bill from Pooja Arora ma'am. What are you doing? Okay, so here we are taking we are extract the total bill column from tips dataset and you can store inside data. Okay, we need only one array. So then after we need to compute mean, standard deviation both as we do in the above example. We are the same mu then sigma is equal to np dot mean data and comma np dot std from data. So we are using now this data set. Okay. and the same step is here. Now come to here. Here also you can see SNS dot his plot data means we are taking 30 KD3 true state density color, okay, and label histogram. Then we will generate the normal distribution, and for that x is equal to NP line space minimum data, minimum value and maximum value. Okay, from minimum and maximum value we can have the interval, particular interval, and the rest of all the values will lie between these minimum and maximum values. And 100 point we are taking here. Okay, this will generate the interval for these values, minimum and maximum value of the data set. And here we will calculate PDF by using norm.pdf x comma mu comma sigma, and the value will store inside PDF. Okay, and then after we need to fit the normal distribution curve, and the same statement is here which we do in the previous example. Okay, no change there. Same process is in this example, just only we have data we download from Seaborn. Okay, and in the previous example we generate randomly, but here we have the actual data set. Okay, and the same data set you can write a CSV file, then you can import. Data is same, no problem, same result will be there. And then we will have to show at a place. Okay, plt dot x label, plt dot y label, plt dot title, and plt dot legend, plt dot show. Okay, so these are the labels and legend, and the above statement plt dot plot. This will visualize the normal curve. Okay, so when we will execute all these statement, yes, you can see. Okay, so this is the normal curve. Okay, in the red color, and the other curve, which is the KDE, you can see here, and then after histogram is there, and red line normal fit. The value of mu we have is 19.79, sigma is 8.88. Okay, so here I put some description about interpretation of the above result. Okay, so see here shape of the distribution. The histogram shows that the distribution of the total bill paid at the restaurant, and the red curve represents the fitted normal distribution based on the data set mean. Okay, mu calculated from the data set. Okay, here we are not assigning the value, but are computed from the data set. And standard deviation, and if the histogram closely follow the normal curve, see this line is very important. If the histogram which we plot at its place closely follows the normal curve, the data is approximately normal distributed. Okay, and for that you have to say the normal curve as well as histogram. So when and how you can observe that this is closely to the normal curve or not. Okay, for that the main thing is the beans which you can see here. Okay, and how many beans? Most of the beans are more than 50% are under this red curve. Okay, approximately. Okay, if we closely to this curve, and you can see this curve is very close to this histogram also. You can see some values are up, some are under this curve. Okay, and here the values of the histogram under this curve, and some values are above. Okay, and here is are also under. So the histogram which is plotted here is close to this normal curve as well as KD curve. Okay, So both are like a similar type. Okay. So not the exactly, but closely. Then we have the mean and standard deviation. The mean represents the average total bill amount, and the standard deviation indicate how much the total bill vary from the mean. Okay, and a smaller sigma, see last line, a smaller sigma suggests that most bills are close to the mean, whereas the larger sigma indicate more variation. Okay, so that depend upon the value of sigma. Okay, if the sigma is smaller, close to the mean. Okay, and if sigma is larger, more variation. Okay, variation inside the data set. And also you can check from skewness and normality check. Okay, for that we must have some basic information about the skewness. Okay, yesterday we discussed about the skewness. If the histogram is symmetric around the mean, the data is normally distributed. And then if the right tail is longer, right skewed, it suggests that a few customers paid significantly higher bill. Okay. And if the left tail is longer, it means some unusually low bills were recorded. Okay. So here, when we observe our curve, and this is the right skewed, you can see right tail is longer. You can see right tail is longer. So when we have the data set and you apply this type of the distributions, and from the distribution how we can extract insight and how we can interpret. This is the very important thing to visualize this diagram. Not a big job. The most important part is how we interpret after visualizing our uh, insights from the data set. Okay, so understand the image, interpret the image. This is the very important part. And for that, you must be very clear all the fundamentals which are required to study. Okay, so here then this is the final insight. You can easily go through all this trend. Now come to here is next binomial distribution. Here is binomial distribution. And I hope all the participants are familiar about the binomial distribution, but still we will revise here and we will talk about the definition. Okay, the binomial distribution is a discrete probability distribution that models the number of success in a fixed number of the independent binary tries with each same probability of success. Okay, and here is the definition. A random variable x follows the binomial distribution if it represents the number of the success in n independent tries where each trial has, say, two possible outcome, success or failure. Okay, and the constant probability of success is p, and this is the probability mass function. Binomially distributed random x variable is given by this the you can say the function p x is equal to k n upon n k. This is the combination, and p raised to power k 1 minus p raised to power n minus k. Okay, and here p n and k. What are n? N is the total number of trial. K is the number of success, which will be less than or equal to n. Okay, the probability of success in each trial. Okay, so when we dose or we have both like success or failure. So, but here P we representing here the probability of success in each trial, and 1 minus P probability of failure in each trial. Okay, and then after nk is n factorial upon k factorial, n minus k factorial is the binomial coefficient. So this is the entire function, and we, with the help of this one, we can calculate the binomial distribution. And here also we put its properties. Okay, and you must be familiar. All these mean will be equal to np, variance will be equal to np into 1 minus p. Standard deviation will be equal to, if you know the value of n and p, then we can easily calculate by using these values, just like variance and standard deviation. Okay, np and under root np into 1 minus p. So square root of variance, we have the standard deviation. And if you need to calculate the mode, then either you will take floor function n plus 1p, or you can use floor function n plus 1p minus 1. So this will be the integer. And for the skewness, you can use to calculate the skewness, we have n 1 minus 2p upon under root np into 1 minus p. And for the kurtosis, we have 1 minus xp, 1 minus p upon np into 1 minus p. So these are the properties, and by using all these, if we need to calculate mean, variance, standard deviation, mode, skewness, kurtosis, we can do by using these properties. Okay, and sometimes if we require to compute. So these are also we have to keep in mind, and these are the applications. Okay, where we can apply coin tossing, the number of heads in n coin flip, and quality control. This is the important part. When we need the quality control, then number of defective items in a page, medical trial, number of the patients responding to a treatment, and genetic, number of the offspring inheriting a particular trait. So these are the some applications. There are many applications, but here we present some few examples. So we can use this distribution. Now, how we can compute binomial distribution? Very simple. And the first requirement is to import the library. Okay, so first these libraries are required. So here, shift and enter. Now next we have to define the parameters which are enrolled inside this distribution. We need the value of n and we need the value of p. Suppose that here n is equal to 10, number of trials are 10, and probability of success is 0.5. Okay, so now we are using inside code. Okay, this is the programming, very simple. N is equal to 10, number of trial, p is 0.5, generate the possible value of k, 0 to n. So here k is equal to np dot arrange 0 to n plus 1. So this will generate the possible values of k, and then after we are computing binomial distribution possibility mass function. Okay, PMF. So here this is the binomial dot PMF, and we need to put these values k, n, and p. Okay, and here we have the cumulative distribution function. Okay, binomial underscore CDF, and you can shift and enter. So all these are computed. Now we have to plot the probability mass function, and here is the code. This is the mathematical formula. Okay, so here what we do, PLT dot figure size we are taking 8 by 5, then PLT dot bar k, and here the values which are computed, binomial PMF. Okay, color we are taking sky blue, edge color black, alpha 0.7, and now everyone are familiar about the alpha. PLT dot x label, number of the success, y label, probability, and PLT dot title we have is the F binomial distribution, n and p. Okay, and PLT dot x sticks we are taking k, and grid we have is we assign the grid here, and then PLT dot show. So when you will execute, yes. So here you can see the number of success and binomial distribution you can see inside this graph. Okay, and when if you will insert the curve, and this is also looking like a bell shape. You can see the data. This plot is looking like a bell shape. Okay, you can see here. So binomial distribution n is equal to 10, p is equal to 0.5. We take the values according to that. We have this visualization. And in the next, here is the interpretation you can do easily. If you need to plot the cumulative distribution function, we can do, and this is the definition of the cumulative distribution of a binomial distribution represent the probability of obtaining at most case success in independent trial, where each trial has a success probability, and p x less than or equal to k summation I is equal to 0 to k, p x is equal to I, where pxi is given by the binomial probability mass function, and you can have the this formula which we discussed in the previous one. And here by using these statement, which are again quite simple, here the values, these values already we have calculated. Okay, we need not require to worry about this one. We have calculated this value in the beginning. So here this statement which we are using here to visualize this CDF, okay, cumulative distributed function. So here PLT, we are using here step function, PLT dot step. Okay, depend upon our choice, we are using histo or step or plot. Okay, so here we have the step plot K, and this is the values which we have calculated. Color red where mid line width 2. These are the other label, X label, Y label, title, and grade PLT dot show. Very simple. Yes. Okay. So these are the number of the success. And on the vertical line, left side, we have the cumulative probability. And on the top, we have the title. And this you can see the graph. Okay. And this graph due to this step. Okay. We use here step. So that's why this is like in this way. Just like a stair step. Okay. This is the first one, then second, third, fourth, and so on. And here is the interpretation. You can easily go through the detail. Very simple. Now we have the just like we will generate the sample for from binomial distribution, and then we can use here. Okay. So here we have the sample. You can see binomial dot RVS we are using RVS. Okay. And n comma p size 1000. Sometimes suppose that we are using this statement. This is all this is for all the participant. Sometime when we are using the statement and we are not familiar what is the meaning of this one, and we need some more information about this statement. So we can take the help from uh, generative AI by using ChatGPT. Okay. Since just like here, I'm taking, okay. And here you can write interpret statement. Yes. Okay, so here this will return all the information about these functions. So is used to generate the random sample from binomial distribution using SciPy state module and the Python. Okay, then scroll down. Yes. So this is the random variate sampler. Okay, RVS means random variate sampler from the binomial distribution. Okay, and some more information will be there about the parameters like n, p, size. Okay, so sometimes if you need some more interpretation about this, and you can easily take help from ChatGPT. Okay, and all the information are there, and sometimes also this will provide you the examples are also there. Okay, so in this way, if some doubts are there, you can go through, and if you need some more examples, applications, okay, everything what you need, you just put the question by using the function put inside there, and ask from the ChatGPT. Okay, so all the information related to this function will be there. So in this way also you can get some more information about all this. Okay, so here we have the samples are generated from by using this statement. And the other statement which you can see are the same, just to visualize. And here we have the hist plot. Okay, hist plot for samples. Okay, and then when we will execute, okay, so this is the hist plot for the above. Okay, so on the horizontal line we have the number of success. On the vertical line you can have frequency, and on the top you can have the random samples from binomial distribution, n equal to 10 and p equal to 0.5. So by using these values we generate this one. First we generate the sample, then we generate this plot. Okay, if you need to calculate compute probability of getting exactly k success. Okay, sometimes if we know the value of k, okay, here exactly 6 success. Okay, so how we can calculate this particular value? This is the code. Okay, k equal to 6 and probability binomial dot pmf knp. Okay, so this value will pass through at a place. The value of n and p are already calculated, so this will automatically pass at this function. And when you will execute, okay, so when we have the exact case, 6 successes, so we have this value. If you have 8, then you have this probability when x is equal to 8. If you take k equal to 1 success, we have 0.0098. So by using this, we can easily calculate exactly success value. Any question, please? Dear participant, if you have any question. Any question, please?
No, sir. Thank you.
Okay. So here again, next one we have the Poisson distribution. Okay, this is also one type of the distribution. The Poisson distribution is the discrete probability distribution that expresses the probability of a given number of event occurring in the fixed interval of the time or space. Okay, so the time or space interval we are given, which will be the fixed, but we have discrete probability. And here is the formula which we can use for the Poisson distribution. Px is equal to k. K is the event, and on the right hand side, e raised to power minus lambda, lambda raised to power k upon k factorial. and the value of k will vary from 0, 1, 2, 3, and so on. Okay, and so according to that, the probability will be computed. And here the k is the number of occurrence, non-active integer. Lambda will be the average rate of occurrence per unit time space. Okay, and e will be the Euler number, which is approximately 2.71828. And these are the properties which we can go through. Mean will be equal to lambda, variance will be also will be equal to lambda, and additivity. If x1 approximate to Poisson lambda 1 and x2 approximate to equivalent to Poisson lambda 2, then x1 plus x2 equivalent to Poisson lambda 1 plus lambda 2. And the applications where we will apply or where it will be applicable. So these are the some examples we try to put here. The number of email received per hour, number of accident at a traffic junction per day, number of decay event per second in radioactive material, number of the customer arrivals at a service center in a given time. Okay, so this type of the for the purpose of the applications we can use Poisson distribution. These are the some examples which you can see, and here we are using SciPy. Okay, so Python provides a Poisson module in SciPy for working with Poisson distribution. And again, it is very quite simple to use. Just you have to keep in mind the formula which we have discussed here. Okay, this expression is very important, and the constant values just like a and the value of lambda and k are required. Okay. So here you can see import numpy as np. This is the library, and the plt is used for visualization. Okay, and then from scipy.state. So the Poisson distribution we can have in this library scipy.state. Okay, from this place we will import Poisson. Okay, then we need to set the value of lambda. We are taking here 5. This is the for example. Okay, if lambda is equal to 5, then generate 1000 Poisson distributed random numbers, and we are using the same function Poisson dot RVS lambda mu is equal to lambda. Okay, and the value of lambda we have is 5, and size is 1000. Okay, so this will generate random numbers. Okay, and then we will plot here histogram. So plt.hist data means we are taking here 15, density 2, alpha 0.6, color B, and edge color we are taking black. Okay. So then plot the theoretical PMF also. Okay. PMF, Poisson PMF. For that we have to take the range np dot range 0 to 15, and PMF will be equal to Poisson dot PMF x comma lambda. This is the function, and then we will plot the PMF by using the same statement as we do in the previous examples. Plot plt dot plot x comma PMF comma. This is the marker used at place. Okay, RO red circle. Okay, a marker size is 8, and label is Poisson PMF. Then these are the other customization like X label, Y label, title, etc. And at the end we have the legend and grid show. Okay. So when we will execute all these sequence of statement, and yeah, you can see at the horizontal line we have the number of the event. Okay, and on the left line you have the probability, and on the top we have the Poisson distribution for lambda equal to 5. Okay, and histogram, and inside we use here red circle, right? So for Poisson PMF, so here you can see these dots. Okay, how the data is distributed under this when we have discrete. Okay, so dot 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 when you will join all these, or you can use at this place. We can use if I make this one. Okay, then shift and enter. Yes, see now. Okay, and here point we take here 0 to, okay, for PMF we not to take only we arrange 0 to 15, no problem. So you can see here the curve, you can observe the data distribution, how the data is distributed. Okay, by using the Poisson distribution. Okay, similarly we can compute Poisson probability mass function. Okay, so here lambda is 5 and k values we are arranging from 0 to 15. Okay, and Poisson PMF will be equal to Poisson dot PMF k values and lambda, and then for k p in zip k values Poisson PMF. Okay, here we are using the for loop. So this will calculate the values for lambda equal to 5, and the value will be printed at the bottom. See, so these are the values. These are the values. So here the value of lambda is fixed, and the other is starting from when we have x equal to 0, 1, 2, 3, 4. Okay, range we have is 0 to 15. You can check it. So corresponding to each, the probability is when we have 0, then 0.0067, 0.0337, and so on up to see the last one. Okay, this is 14. X is equal to 14. Okay, so all the probabilities corresponding to this we have computed. Since it is starting from x equal to 0. Okay, but we put here the range is from 0 to 15. So these are total we have is 15. Okay, index is starting from 0 to will go to up to 14. Okay, 14 means this is the 15th. And then after cumulative distribution function, if you need to compute, we can do here also. If we have the k equal to 7 and we need Poisson cumulative distribution function. So here Poisson dot CDF k and lambda, but lambda is but the value of k is 7. Okay, so when you will execute probability when x is less than or equal to 7, we have is 0.8666. Okay, if you will take at its place 1, if you will take at its place 1, okay, so this will compute when x is less than or equal to 1, which is 0.404. Okay, and if we have at its place 0, then we have 0.0067, and see now these values, this value. Okay, and when you will take here x equal to 1, sorry, k equal to 1, then 0.0404, the value of x is less than or equal to 1, means 0 and 1. Okay, so this is the sum of these two values. Sum of these two values. Similarly, when you will take here 5. Okay, so this will calculate the probability for all those values which are less than and equal to 5. Okay, for 0, 1, 2, 3, 4, 5. This is the total here. Then what are the application of Poisson distribution? These are given here, modeling the number of email. We have go through this detail. Okay. So here using probability distribution in Python. Here are some more examples you can find here. Python provide powerful libraries such as SciPy, NumPy, Matplotlib. We have discussed many things. And with the distribution, the most commonly used distribution, normal, Poisson, binomial, exponential, and more. So here, these are the required libraries. And I think we put here many examples here, and you can easily go through all these. Okay, yeah. So some more examples. Actually, all the distributions we have discussed here. Okay, but here some more examples are there for your practice, and you can easily go through all these functions which are available here. So this is all about the today's session. You can go through all these plots. Okay, we have discussed all this part, and the above examples are using the Matplotlib, and here some examples will be there by using Seaborn. Okay, here we are using Seaborn. We have the normal distribution, same examples are there, but in a different parameters. Various examples are put here. Okay, here is the example of the exponential. Yeah, this exponential distribution. Okay, but we did not define in the previous. Okay, so here generate the exponential distribution data. We are taking the lambda is 1.5 and data is equal to np.random exponential function, which is inbuilt inside the library. And the scale we are taking 1 upon lambda, size 1000, and SNS library is there, plot, and these are the other statement to plot the graph. Shift and enter. Okay, so this is the exponential distribution. And in the case of exponential, the graph will appear like in this way. You can see. Okay, so starting from this will be either in increasing or decreasing depending upon the value of lambda. Okay, so if the power of A is positive, then this will increase, and if negative, then it will decrease. Like always will be in this way. And as soon as this will approach to infinity, this will become 0. Okay, so this is the exponential distribution. Here also we put, I think, some examples, multiple distribution to compare. Okay, sometimes if you need to compare a multiple distribution when you are trying to 2 or 3 distribution for your experiment, okay, and you need comparison, then all the plot must be in the single image. So here are the statement. You can see here caddy plot, data normal, then we have the data exponential, and when you will plot this graph, yes. So in this graph you can see normal and exponential both are together, and we can easily compare this graph. So I think some more examples will be there. Hypothesis testing. This part is also very, very important, but we will discuss about hypothesis testing tomorrow. And further today, we need to cover only the all type of the distributions, and we are able to cover now. And some of the examples, if in the latter, if I skip just for you only. Okay, so since the repetition is there, different parameters, and to represent the same data in a different way, multiple images are provided for you so that you can do some experiment, and you can use these expressions also. Okay, so this is the detail about the today's session. 4 distributions we discussed, and one part is missing in this the function for exponential distribution, not inside in this file. So after providing that one, I will share with you. Now, if there is any question from your side, you can ask from me, and I hope that the content which we present today are quite simple. Just need to only how we can import the data and how we can create data, how we can use the data which is available in Seaborn to visualize or to fit the normal distributed curve, binomial distributed curve, okay, and exponential distributed curve, Poisson distributed curve. So all these are very highly useful when you are talking or thinking about the statistical analysis. You want to establish like recommendation model or prediction model. So machine learning models are also there. So all these type of the distributions are highly required, but it depend upon again for which type of the study we are doing. So according to that, we need to choose. But here, application part also we try to provide along with every example, so that whenever you will go through all these content, will be very helpful, and you can uh, go through the details with examples. So you can choose your own data set, do the experiment. If you need some more data set from his side, I can provide you. Okay. But the most important thing is you have to use all these content as well. The codes how we are using, you must check by changing the values of the parameter. Okay. And in this way, whenever you have some experimental task, okay, and you are playing with the code, then this will add some value, and you will be expert in importing the data and to draw some insight from the data set. So the session is open now for you. If you have any question, please feel free to ask from. Yes, anyone, please. Any question, please?
No, sir.
डॉक्टर प्रिया राठौड़ मैम, कहाँ से हो आप?
I'm from Indore.
इंदौर, great.
Yes, yes. From St. Paul Institute of Professional Studies.
Okay, okay, okay. So ma'am, your background?
Yes, I'm assistant professor.
Actually, I from mathematics.
Yes, yes, sir.
Okay. So the content which I am trying to present are helpful for you, or you have more
Yes,
advanced skill
yes,
than.
yes, sir. It was very nice. It was very nice, and all the commands are same. So is then easily learn from.
Okay. So and any suggestion, ma'am, from your side if we can improve the quality or anything?
Uh, no, sir. Every time I join your session, it was very nice. No, sir.
Okay,
It
thank
should
you.
future. It should be continuous also.
Thank you, ma'am. Most welcome. Always welcome.
Okay, sir.
Uh, Thank you, ma'am. Uh, Kramjit Kaur, ma'am. Today we have some time to talk with you. Yes. Uh, Kramjit Kaur, ma'am, or Dr. Manpreet Kaur. Pooja Arora, ma'am. Navneet Kaur. Okay, and we have Suhair.
Yes, sir. How are you?
Yeah, I am fine. About you?
Alhamdulillah. Fine. Thank you so much.
Yeah, I ask if there is any question, please.
Oh, no, no. Thank you. This is very beneficial to me. This is first time I take something regarding Python. I needed to make some program for manufacturing, but this also will have a mathematical part because of taking the batch, the percentage of the batch, and the test. We will do something like this. So this is very beneficial. Not all thing you represent is related to my work, but now I feel confidence and I have. Very good idea regarding the functions and other things. Thank you so much, sir.
Ma'am, what is your research area? In which area you are working?
I'm working with tanneries, leather manufacturing.
Okay. So,
Yes,
uh, what type of the mathematics is there?
we are taking the batches of the leather, also the percentage of the chemicals. We need now for the new standard to have what you call this one to have balance between the chemical intake and the test we done for the leather. So this contain a lot of calculations. So that's why we need Python to make ERP for the tanneries in the future. That's why I'm interested in Python.
No, I want to know, is there just like mathematical application, mathematical models, or only the statistical models are applicable?
Wallah, to be honest, I don't know what the difference between them, but in general, I can say like this: every 200 batch, we make
Okay.
chemical test. Then we calculate the balance for each chemical before and after. Yani before the leather intake it, for example, we give 200 gram of chrome. We
Mm.
need to increase this intake and decrease the chrome going with the water, with effluent water. So this one needs some calculations for the quality test. I'm interested in making a program, as I said, for manufacturers, for tanneries. So they will not calculate it manually as they do. They just put the recipe sheet and the test they do immediately in the program. Then they will
Mm.
get the result. It's, if it's okay, if it's high, like this. So that's why I'm interested in functions more. So if it's مثلا more than 20%, stop the operation, do this, put like this, something like that.
Okay, you must collaborate with us. We have a team and we are working in interdisciplinary as well for the risk analysis. Okay, you can use Python and Matlab is also there, very helpful. Whenever you need some more accurate findings and the results, if you need. Matlab is also there, you can use for the risk analysis, but by using the Python, you can do also. Okay, so here in the coming sessions also, I try to introduce one or two example on the basis of the how we can apply for the risk analysis model. Okay,
Yes, please.
so
Yes, thank you.
I think according to whatever you talk with me, statistical part is highly useful for your work.
Yes, yes. So I need
Yes.
to look for Python for structural. يعني
Python.
which uh-huh.
Uh, there are several libraries in the Python, and if you will be familiar and how we can use the Python, okay, then you can switch also for MATLAB. Okay, there is only the syntax difference, but there are some toolboxes in MATLAB which you can use for your work also. But first, you need to focus only on the Python and the ongoing topic which we are discussing here. Okay, and whenever this course
Yes.
will be completed, then you must analyze, and if possible, you can share your some work with me so that I can also go through. And you are from which place?
I'm from Jordan, but the company I work with in India, in Chennai.
Okay, okay, you are from Jordan.
Yes, yes. I live in Egypt and I work with Indian company in Chennai.
Okay, now you are in India.
No, no. Now I'm in Egypt.
Okay. Okay, okay.
Yes.
Jordan, very nice place. And
Thank you. Thank you.
do you have your like uh, Google Scholar link?
Yes, yes. I think long time. Yes,
Share
I
with me.
have one. Yes, yes.
How many publication you have?
I was working with Agriculture College in UAE University. It's not related to mathematics, but because I have a high diploma for quality control, I work with manufacturer also. So
Okay,
a
okay,
little
one.
bit distance, but
Okay, okay, good, good. I want to know how many publication you have.
yes, I will send the link for you, sir.
Okay, please share your Google Scholar link with me. Okay, and
Yes,
yeah, I think you can collaborate with also since we have a colleague who are working in agriculture, and recently we collaborate and we are working on agriculture as well as health science. Okay, I am purely mathematical background, but since last 5 years I switched to like statistical and machine learning model, mathematical model, and their applications in health science, environment, and agriculture. So recently we have write 3 papers on agriculture and in the pipeline, and very soon they will be there. So just like you are talking about the quality control, risk analysis, I think this will also help us to collaborate. And also all
yes,
the people who are attending this session, if anyone want to collaborate and need help, always open, and we are completely open-minded to work together. Okay. Sometimes, actually, these days, the research completely is interdisciplinary. Okay. One person cannot be complete in or perfect in every domain. Okay, suppose one person we want to research in health science. Okay, so without the help of the doctor, we are not able to do this type of the research. Okay, so statistician, computer, or who is expert in AI or mathematics background is also required. Okay, so when we from different domain are comes together to work and like-minded, then we can contribute a very good work. Okay, so thank you to all. And Umar, how are you?
Hello, good day, sir. I'm fine, sir.
I am fine. You can see I am great.
Yes, yeah, I see, sir. Yeah.
Yeah,
So actually, sir, I'm a MSc student in here in India.
in
So
India.
yeah, yes, sir.
Which city?
In the Greater Noida Sharda University.
Greater Noida, Sharda University.
Yes, sir.
Oh, in the 28th Feb, I was there.
Yeah, surely, sure. You I had your lectures there around. Is it from Department of Mathematics?
Yeah, okay, okay, okay.
There's one workshop organized by Department
Khurshid,
of Mathematics and Data
yeah, yeah, yeah.
Science.
Khurshid Alam is there, head of the department.
Yes, sir. Yes, sir.
Yeah, okay, okay.
So, sir,
So
yes,
you are
sir.
from Nigeria?
Yes, sir. Yes, sir. From Nigeria, Nigerian student.
Great. Nigeria is a very great country, very
Yes,
nice
sir.
people, and many
Indeed,
people
sir.
from Nigeria are connected with me. Usually,
Yes. Yeah, yeah,
yeah,
yeah.
many people are with us.
So, so currently, Sam, I'm trying to take a research in the physics under energy storage. So I
Okay.
want to see the possibility of using this Python. Is it possible now to make use of the Python for simulations, like say in the absence of laboratory, can I use the data gotten from one paper or the other to make a simulation so that the result gotten can be make use of in the laboratory to test it, either the simulation works or not, instead of using the chemicals to be testing it or to be carrying out the experiments once, twice, or so on and so forth. So once, can I use Python in a short time to input the data, got the result, then I take it to the lab?
Yes, you can use Python,
Yeah.
but MATLAB is more, you can say, uh, we can have more accurate result if you are using
Okay.
MATLAB for the
Okay.
simulation. Okay,
All
especially for
right.
simulation. Okay, so a special simulator is there inside the MATLAB, and
Yes.
I think MATLAB license is available in Sharda University.
Yes, sir. Yes, sir.
Yeah, so you can use, but the syntax in Python and MATLAB, very
Yes.
little difference. If once
Okay.
you understand how we are using the Python, and also the one more thing, you can use Python in MATLAB.
All right.
Okay, so
Okay.
there is no big difference in the syntax or the little bit difference may be there, but not much difference in MATLAB and Python. So that's
Okay.
ongoing will help you. But also you can do in Python, since Python is free available, open
Yes,
source.
sir.
Times when you will go to your country back and you don't have MATLAB, as actually MATLAB is a commercial software and
Yes,
highly
sir.
we pay. Okay, so you must be familiar along with the Python as well as MATLAB.
Okay. Thank you, sir.
Yeah. And if you need any more help, always you can easily contact us through
All
WhatsApp.
right. Okay, sir.
Okay. Yeah. Thank
Thank you,
you.
sir. Thank you. Thank you, sir.
Thank you. Nice talk with you. Yeah.
Good evening, sir.
Yeah. Good evening. I was waiting for your voice.
Yes, Prof. Yes.
I was thinking,
Yeah,
why not to unmute your mic?
No,
How are
no,
you?
sir.
How are you?
I'm fine, sir. So thank God, Prof.
What about the today's session? Did you attend the entire session today?
Yes, yes, yes.
How was?
At least I'm getting something related to my specialization gradually.
Okay.
Mm.
Okay.
My question is just that those plots, the graphs that we have been plotting, how can we export them as image to
Okay. How we can export or import?
no export those map, those chart, the graph, the bar
Okay. Okay.
chart,
Okay.
the
Yeah. Just 1 minute. I am checking how we can. Please give me 1 minute, please.
Okay, Prof.
Okay, so I am sharing my screen, and you can see here is my screen. Just 1 minute. Okay, and yes, screen is visible. Okay, so here you can write. See, if you want to save your image in PNG format, then you will use this statement, plt.save fig figure. Okay, and here you will give the name. Here you will give the name of the file. Okay, and if you want to save in PDF, then you can use this statement. Only you need to change the extension. So, and if you want to change, save the file JPG and DPI 300. Okay, this will improve the quality. Okay, high resolution. So according to that, you can change the DPI. Okay, so I comment this statement. I comment this statement also. And I want to change, I want to save this image with the name of myplot.jpg. Okay, so when I will execute shift and enter, yes, so where I can check it, I have to, yes, you can see this is the myplot.jpg. Okay, so this the images will save automatically in your current directory. See once again, this is the, yes, here if you will give the name, suppose that this is binomial distribution. Okay, then execute the entire shell. So this will do both tasks. This will show the image and this will write the image. Okay, see, shift and enter, very simple. Come back. Yes, here is the file, binomial distribution.jpg. And if you want to open, double click on it. Here, yes, you can see this is the image. Okay, same image is there. So depend upon your choice which format you want to use. Okay, and in this file, which I will share with you again. Okay, I put all these three formats which you can use for your image. Just you need to replace this name. Okay, this is used for PNG. If you need PDF, then you will use here extension PDF and name. So the function to save the file is plt.save fig figure. Okay. So inside you will give the you will put the name and then use the extension. DPI is used for only for JPG extraction, not for PNG or PDF. So this is the way to export your image. Okay, got it?
Yes, sir.
Okay, dear participant, thank you to listen this lecture very patiently. And tomorrow we will join at the same time, and I will wait for you. Okay, at 7 p.m. and 2 hours we need. Once again, thank you to all to join today's session. Good night and stay connected.
Thank you, sir.